Storm Ashley hit the UK over the weekend, having explosively deepened across the Atlantic in little over a day. It came out of nowhere and became a very, very deep low indeed. Why did Ashley deepen so quickly? And are we likely to see a repeat in the next week or so? I'm going to be answering those questions in this week's Met Office Deep Dive. Welcome along. These can be found on the Met Office app and the Met Office YouTube channel. There are plenty of videos like this on the Met Office YouTube channel, so if you haven't discovered them yet, I do urge you to subscribe, especially if you're a fan of the weather like we are. And if you know any other fans of the weather, do let them know. Before we talk about yet more wind and rain, I just thought we'd take a moment to marvel at some fog. This drone footage of fog near Axminster was taken by my talented colleague Rich from his drone. And you can see the moment at which the drone rises through a layer of fog close to the ground and transforms the view from this gloomy autumn day to bright blue skies. Absolutely stunning. So if you ever wondered when you're wandering about in the fog and thought how gloomy it was, well, it's not, you don't have to go far sometimes to see the sun coming through and to see the blue skies. And we'll see more of that sort of thing in some places on Wednesday morning, with lighter winds and clear skies across East Anglia, say, parts of southeast England. Wednesday morning is the morning this week where we're most likely to see some dense and widespread fog. But otherwise, we're back to talking about wind and rain. And before I talk about more rain on the way in some parts of the UK, let's just have a look at the satellite image from Storm Ashley, because it really was quite a fascinating system as it deepened over the Atlantic. Now, before Ashley arrived, Friday we saw a different low pressure. This is another low that was sitting over Iceland and brought this band of rain west to east across the UK and some strong winds, especially across northwest Scotland, accompanied by high tides, and of course we saw coastal impacts as a result. At this stage, this is 1 a.m. on Saturday, Storm Ashley is just a shallow area of low pressure, essentially this wave of cloud. So you can see what meteorologists call a cloud leaf. It looks like a leaf, doesn't it, in the satellite imagery? This bulge of cloud emerging, and we'll just fast forward a couple of frames there, and you can see it starting to really explode in its development. Now, explosive cyclogenesis, that's the technical term. Obviously, the term weather bomb has been commandeered by some tabloids to make the weather sound even more exciting and frightening, but actually explosive cyclogenesis is a genuine meteorological term for areas of low pressure that deepen by more than 24 millibars or hectopascals in 24 hours. And certainly Storm Ashley met this criteria as it deepened during Saturday. And I'm just going to scroll slowly through the satellite imagery. You can see that low pressure center forming just by there, and the trailing area of cloud with bands of rain heading into the UK. Putting the radar on there, you can see the rain reaching western parts at this stage. Before, during Sunday, the strongest winds reached northwestern parts of the UK. So why did it explosively deepen across the Atlantic? Some of the clues lie in the type of cyclone, type of area of low pressure that Ashley was. And just to give you a brief history lesson before I draw a pretty picture, back in the early 20th century, a group of Norwegian meteorologists developed a model of low pressure systems in the northern hemisphere or North Atlantic by looking at surface areas of surface observations. And what they realized was you get these big temperature contrasts across an area of low pressure. And so they realized that there are these strong gradients that we now know, they called them weather fronts, basically. And they came up with the idea of warm fronts. We're all familiar with this now, having talked about weather fronts and warm fronts and occluded fronts and so on in weather broadcasts over the years. They came up with the idea of a low pressure system having, first of all, a flat, what we call a wave, where you've got warm air pushing north and cold air starting to push south. And as a result, with the help of the jet stream, eventually you get a more pronounced differential developing and a little circulation. So let's draw that. Little circulation here with a warm front like that and a cold front. So this is the development stage of an area of low pressure. And then eventually what the Norwegian model says is that the cold front overtakes the warm front or catches up with it. And you get, I haven't got purple, that's annoying. Didn't think this one through. I've only got 3 colours to choose from. Let's draw it blue. Pretend this is purple. This is the occluded front. You get an occlusion when the cold front catches up with the warm front, essentially. So that's the Norwegian model. But then in the 1980s, another couple of meteorologists called Shapiro and Kaiser developed a slightly different model of a slightly different area of low pressure because they looked at satellite observations, they looked at numerical weather predictions, so computer modelling, and they realised that not all low pressure systems form like this. Not all of them have an occlusion process like this. So they realised that although their model starts in the same way, with a warm front and a cold front like that, what they realised is that in some cases the cold front, wrong pen, the cold front fractures like that and ends up in something called a T-bone structure, a right angle situation. They don't join together. The next stage after that, because they don't join together, they don't occlude, you don't get an occlusion, is that the warm air wraps around the area of low pressure and the cold front continues like that. Why is that important? Well, because this area of low pressure, the Norwegian model, has a cold core. The cold air is within the low pressure centre here. Whereas the Shapiro-Kaiser model has a warm core. So that makes a difference in terms of its development, particularly over the ocean. And these are more common over the ocean, by the way, because you've got more energy, more moisture as a result of that warm core. And that makes it more likely to explosively deepen. And looking at the satellite imagery from this, let's see if we can annotate its evolution through the Atlantic. And early Saturday, this is when it started to develop significantly. Jumping over to this side, there's the cold front. And this is a very simplified idea of what's happening. And there's the warm front, and you've got the warm core in the middle. And as it moves, you can see how quickly it deepens. And eventually, by the time it arrives into the UK, all this warm air, it's called a warm seclusion, by the way, wraps around like that. There's the cold front trailing behind. And it's within that warm core, this warm seclusion, you've got all this energy and moisture. That's what leads it to rapidly deepen as it approaches the UK. And it's within this area that we saw the strongest winds. We did see gales across western parts of the UK early in the day as the band of rain moved through, the main band of rain. Then there was a lull in the winds as the centre part of the low pressure started to approach. But it's within this core where we saw the very strongest winds. And by Sunday evening, it was about 8 o'clock. I'm just zooming into the UK. It was at this point that Tyree recorded a wind gust of 78 miles an hour. You can see there's the centre of the low pressure near Stornoway, and you can see this swathe of very strong winds, heavy rain pushing into Tyree. Now, Tyree's gust of 78 miles an hour on Sunday at 8 p.m. was the strongest wind gust at that site since February 2016. That was Storm Henry, and it was the strongest October gust at Tyree since 1972. So it was an unusually strong windstorm for Western Scotland. Even for Western Scotland, where you get these storms in the autumn and winter, it was particularly notable. It wasn't just Tyree. Killowen had a wind gust at the same time of 81 miles an hour, and Abdaran earlier in the day had a wind gust of 82 miles an hour. So that's North Wales, there's Killowen in Northern Ireland. So yeah, a particularly notable area of low pressure. I just thought I'd talk through that because I found it interesting anyway. I hope it made sense to you. Now let's take a look at the weather over the next few days first of all. I mentioned the fog overnight across East Anglia in the southeast. That's the first thing that is of notice, or the first notable thing in the forecast during the next few days. And what you're seeing here is there's a pressure diagram on the left. There's the weather, the cloud and rain and fog on the second from the left. And then there's the winds and there's the temperature. So by dawn on Wednesday, what we've got is higher pressure just to the southeast of the UK, isobars well spaced, a few showers across the far south of the UK, but otherwise quite extensive low cloud and fog forming, mostly fog across East Anglia to the northern home counties, London perhaps. Very poor visibility first thing, so if you're travelling first thing on Wednesday, then do take care on the roads. Fog's unlikely to be an issue across Scotland, Northern Ireland, northern and western England because there's more of a breeze, as you can see on this graphic, a bit more of a breeze there for the north and the west of the UK. So it's the southeast corner of the UK. That's where the lowest temperatures will be as well. So we're talking about 8 to 10 Celsius in main urban areas, but 5, 6, 7 Celsius in more sheltered parts, perhaps a little lower in some of the most sheltered parts of the UK. But fast forward into Wednesday afternoon. The fog will clear likely around about 10 Z or 11 local. So 10 Z, 10 Zulu. Zulu is UTC equivalent. So the way that, it's quite a nice trick actually this, the way to figure out fog clearance is, if you haven't got access to anything else, is to take the month of the year, or how many months you are from, say, December, and subtract it from midday UTC. So we're 2 months from December, so that's 10 UTC, and that just is basically a rule of thumb that takes into account the fact that the sun is getting weaker and weaker as you head towards December. So take December. In December it would be midday UTC, in November it would be 11 UTC, this time of year 10 UTC. The computer models agree with this, other meteorological techniques agree with this. For tomorrow morning's fog, most likely to be 10 UTC, which is 11 local time. Of course, the clocks fall back this weekend, so it would be a different time. If it was this time next week, it would be 10 local, but at the moment it's 11 local time. Anyway, it's clearing at 11 a.m. and then it's sunny spells for much of England, Wales. It turns increasingly cloudy for Scotland and Northern Ireland. There's a few showers around, but it turns increasingly cloudy for Scotland and Northern Ireland, increasingly breezy as well. And then things happen really slowly through Wednesday night into Thursday as well as Friday. There's a cold front approaching from the west. That's thickening up the cloud, and by early hours of Thursday, that's bringing outbreaks of rain into the far northwest of Scotland. But you can see how slowly it's moving. It's really taking its time. Meanwhile, Thursday morning, unlikely to be as foggy in the southeast because, as you can see from this graphic, there's more of a breeze. Isobars are tightening up ahead of the front as it pushes into the west. Meanwhile, the front develops an area of low pressure. So you've got, similar to the basic diagram I drew earlier, you've got a warm front, cold front wave situation that then starts forming a circulation. So that's happening to the west of the UK. Band of rain very slowly moving in for the start of Thursday. But for most, Thursday starts off dry, less fog around, best of the sunshine in the east of the UK, breezier in the west. Then it turns cloudy by the end of the day across all parts. But by the time you get to Thursday evening, you can see Western Scotland, Northern Ireland, parts of Pembrokeshire, Cornwall, for example, seeing outbreaks of rain move in, but it's taken all day to get there. And there's some uncertainty, which I'll go into in a moment, about how much that will move in through the course of Thursday and overnight into Friday morning. Either way, it's a mild day. We've got southerly winds, and it's actually mildest towards the southwest. Now we can show that by a nice new graphic that I developed. See what you think about this. This shows 2 p.m. Tuesday, Wednesday, Thursday, Friday, and it shows the temperature at 2 p.m, the highest temperature and the lowest temperature across the UK. So, for example, Torquay, hot spot at 2 p.m. today. We'll see if that is the case by looking at the observations later. 17 Celsius, whereas Orkney, 8 Celsius. And then by Thursday, you can see it's Bideford in the southwest that's 16 Celsius, whilst it's actually northeast England where we've got 11 Celsius. And that's interesting because actually that's likely to be a sunnier place, but at the same time they've probably started colder because of those clearer skies overnight, whereas Bideford has got those strengthening southwesterly winds, so importing milder air ahead of the front. Then by Friday it's all changed again. The warmest place is in the southeast, 15 Celsius, coldest place at 2 p.m, by the way, this is at 2 p.m, not the maximum for the day, is Glenann in Northern Ireland, so 9 Celsius there, and I'll explain some of that in just a moment. But let's take a look at why that band of rain is so slow moving. And to explain why, we have to look at developments on the other side of the Atlantic. And let's play this sequence forwards. What we've got at the moment is an area of low pressure down here called Tropical Storm Oscar. It was Hurricane Oscar. Very briefly, it reached hurricane status near the tip of Cuba, the eastern tip of Cuba. And it was the smallest hurricane on record, with a hurricane force wind field of 5 or 6 miles. So Oscar, notable for being the smallest hurricane on record. It's now moving north as a tropical storm. It didn't last as a Category 1 hurricane for long, of course, being so small. It's now moving north as a tropical storm. It's going to weaken considerably. But what it does do, and this low up here also does, is it causes some uncertainty in terms of the shape of the jet stream later this week. And that's because what we're seeing from this area of low pressure is a warm front, a plume of warmth being pushed north into Greenland. And then Oscar joins in. Of course, Oscar, being an ex-hurricane, being a tropical storm, also contains a lot of moisture and warmth. That then moves north. And so we've got these two pulses of warm air moving north on the other side of the Atlantic. What does that do? It pushes the jet stream north. And that has downstream consequences on how far south the jet stream ends up diving out to the west of the UK. So like cracking a whip, you induce a ripple on one side of the Atlantic, and that then has an impact on the other side of the jet stream. The jet stream pushes north over Greenland, dives south to the west of the UK. But this is a small tropical storm and another area of low pressure that are both interacting with the jet stream in slightly uncertain ways over the next couple of days that then has consequences on the shape of the jet stream. So naturally, by Friday, there are uncertainties about how amplified that jet stream is, how loopy it is, how wriggly across the Atlantic, and how far it extends south. If the jet stream is particularly amplified because you get a lot of warmth pushing it north over Greenland, and that then ends up forcing it even further south west of the UK, if it's particularly amplified, then the whole band of rain, this frontal system, becomes even slower moving. You get more rain over Northern Ireland and Western Scotland during Thursday and into Friday, and you get potentially a deeper area of low pressure forming close to the UK. But if it's not as amplified, then the system moves through slightly quicker. You get less rain in the west, less deep of an area of low pressure, and so on. So there are some important consequences as a result of the interaction between Tropical Storm Oscar and the area of low pressure moving into the Davis Strait over the next couple of days that we'll be monitoring closely. That also has ramifications on the weather coming into the weekend, because how amplified the jet stream is on Friday will continue to impact the weather across the UK during Saturday and Sunday. More on that in just a moment. But let's just take a look at what the different computer model simulations are suggesting for the area of low pressure that could develop on the frontal system as it moves into the UK during Friday. I appreciate it will be difficult to see this clearly, so I'm going to do an Alex Deacon and draw the UK on for you. If you watched the deep dive last week, he did the same thing. Let's see if I can draw an even better area of the UK here. I doubt it. My drawing skills are very poor, particularly. I've chosen the wrong colour anyway, yellow. So it's not at all clear, but yeah, that's basically the UK. Let's switch pens, blue. And each dot here is from a different computer simulation for the area of low pressure that's likely to form on Thursday night and into the start of Friday. Now there's a cluster just off Pembrokeshire, so that's the most likely area for the low pressure system to form. But there's another cluster across parts of southern Scotland, for example. So there's some uncertainty about an area of low pressure that's forming on a weather front as it moves in from the west during Thursday, and the location of that low and its depth will have important consequences on how fast the rain moves through and how much rain we get, most importantly, across parts of Northern Ireland and Western Scotland. This is from one computer model run. This shows the 24-hour rain totals across the UK, Tuesday, Wednesday, Thursday, Friday, and it picks out Northern Ireland there and Western Scotland as the place most likely to get large rainfall totals later Thursday and into Friday. But just to give you a probabilistic viewpoint, this takes the output from all the different computer model runs and highlights the probability during that period. Let's choose a more appropriate pen. There's the UK, Wales, Scotland, Ireland, and as you can see, it picks out Western Scotland and Northern Ireland as those places most likely to get more than 50 millimetres of rain through Thursday and Friday. So, to summarise all of that, Oscar and another low likely to cause the jet stream to become more wriggly, more loopy over the Atlantic. That then slows down a weather front as it moves into western parts of the UK during Thursday and into Friday. If it slows down enough, then not only will we see a lot of rain across Western Scotland and Northern Ireland, 50 mils or more, but we're also likely to see an area of low pressure forming, most likely somewhere near Pembrokeshire, which will, again, add to the rain across western parts of the UK. Not much rain further east, but add to the rain in western parts of the UK. And we're likely to see some stronger winds developing across southwestern parts of the country. And just to give you an idea of that, this is Friday. Well, let's take you to the end of Thursday first of all. We've got the rain moving in. There's the rain into western parts of the UK. It is slow moving, but at this stage, we've got the potential for low pressure to form in this area. And that is likely to slow things down even further. But also, as the rain moves away eventually during Friday morning, clears east, lingers across northern Scotland perhaps, we've got some very lively showers moving into the south and west of the country, perhaps some thunderstorms, especially towards the southwest, where there'll also be some strong winds with the potential for 50-mile-per-hour wind gusts. This again gives you a summary of each day over the next few days, Tuesday, Wednesday, Thursday, Friday. And just to pick out, first of all, Wednesday, as the low approaches, the chance of some strong winds, 50-mile-per-hour wind gusts, that's what that's showing for northwest Scotland. Then, on Friday, these are the wind gusts. Nothing as strong as the low pressure systems that we saw at the end of last week and through the weekend, but still some notable wind gusts towards the far southwest, 50-mile-an-hour wind gusts perhaps, and that does depend on the depth and the location of the area of low pressure, and also through the Irish Sea, some fairly lively winds developing during Friday. But it's unlikely to continue that way because what we'll see is those systems clear out of the way and then a brief gap actually heading into the weekend. So, a breezy and showery day on Friday. Another band of rain moves into western Scotland and Northern Ireland, as well as West Wales and the southwest Saturday morning. A drier spell in the southeast. And this, by Saturday and into Sunday, as another band of rain moves into the northwest. is the next aspect of the forecast that is slightly uncertain because it depends. It all comes back to that shape of the jet stream. And in this case, if the jet stream is flatter across the Atlantic, which it may well be, this is how it's looking on Saturday. If it's flatter, then you get these weather systems basically being forced west to east across the country, and quite a lot of warmth being pushed in as well from west to east, and a lot of rain building up across western Scotland, northwest England and Northern Ireland. That's if the jet stream's flatter. If the jet stream's a bit more wriggly, then these weather systems move through quicker. Either way, through the weekend, we're likely to see these systems move in from the west. One of the systems, really it's later Saturday and into Sunday, contains the remnants of Tropical Storm Oscar. That's this system here. So this is the remnants of Tropical Storm Oscar. Not at all a tropical storm, of course, at this stage, but its tropical origins mean that it's, well, not only adds to the uncertainty through the weekend in terms of timings and speeds of weather systems as they move through, but also contains some additional moisture, so could end up with quite a wet spell across western and more especially northwestern parts of the UK. So this weekend's likely to be very mixed, in other words. We're going to see weather systems move in, not just one, but a few from the west, and those weather systems are likely to mount up the rainfall across western and northwestern parts of the country, especially over hills. And so that's definitely something we'll be keeping an eye on here at the Met Office. And those uncertainties continue into the start of next week. However, what looks most likely into next week is that higher pressure towards the south of the UK will begin to build near the UK, but more likely just to the west of the UK. So influential, certainly, but not necessarily leading to completely settled, sunny weather across the country. For starters, we're likely to see some weather fronts trapped under that area of high pressure at first, so we could see quite a lot of cloud and some rain and drizzle through the early part of next week. And secondly, and this is interesting, this is showing, oh, by the way, that was a pressure anomaly graphic, should have explained, for the whole week, Monday to Monday, next week. And this shows the pressure anomaly from the European model, so how much lower or higher the pressure is compared with normal, and it shows higher than normal pressure just to the southwest of Ireland. But when you look at the same model and what it showed for the previous run, 24 hours earlier, and the run previous to that, 24 hours before that, it showed higher pressure. So this is the most recent model run here. This is 24 hours earlier. It showed higher pressure closer to the UK. And this is 48 hours earlier, top right, higher pressure quite close to the UK. There's been a subtle change in the last 24 hours. The higher pressure is a bit further west of the UK. Why does that matter? It matters because of wind direction. This is showing the same thing. So this is the most recent model output for the temperature anomaly through next week. And what it's showing is a greater chance of northwesterly or north-northwesterly winds, and as a result, blues over the UK, so lower than normal temperature through next week. 24 hours before, it was showing average temperatures. 48 hours before, it was showing average temperatures. So a subtle change in the computer modelling in the last 24 hours, shifting that high just a bit further west of the UK, allowing perhaps some colder winds at times. Either way, this is showing the rain anomaly through that same week, Monday the 21st of October to Monday the 28th of October. Oh no, it's 28th of October to the 4th of November, I beg your pardon. So last few days of October, first few days of November, rainfall anomaly, and it's showing drier than average across most of the UK, but particularly towards the southwest. Of course, that's where we normally get our wetter weather. It's showing average rainfall for the north of Scotland, and it does seem likely, looking at some other output, that we'll see still some changeable weather across northern Scotland through that period. So drier towards the south and southwest, weather fronts and showers continuing to affect parts of northern and western Scotland at times through next week. In other words, settled for many, but not for all. And then after that, there are signs that that high pressure will move, but this is where paths diverged. Some computer models shunt the high up towards Iceland and Greenland, forcing the jet stream south and more unsettled weather into the south of the UK. This is the first week of November. Other models have the high building over Europe, which would end up with westerlies for the UK and the most unsettled weather across the north and northwest. So, yeah, still to be determined what happens after the first few days of November. A lot of uncertainty by that stage. But of course, we'll keep updated right here at the Met Office. And that's all I've got for you this week. Apologies if it was a little bit confusing at times. Still getting to grips with the new screen. Drawing things, not my forte, but hopefully it adds to the explanations anyway. And if nothing else, hopefully it's cheered you up to see someone like me struggling with technology and getting to grips with simple things that my daughters can do with a pen. That's all anyway. Thanks for watching, and we'll see you again next week. Bye-bye.